Okay, so in this video homework, I'm going to draw a structure on the board, just a generic structure with no 3D information, and I'm going to ask you to tell me how many possible stereoisomers there are. Alright, there's a chlorobutanol. It would be 3-chloro-2-butanol, right? 1, 2, 3, 4. The OH takes priority. Okay, so tell me how many possible stereoisomers there are. Hit pause, try to work it out. Okay, you have to answer this question, you have to first determine how many chiral centers there are. If you didn't do that, if you didn't count up how many chiral centers there are, hit pause and do that now. Alright, if you did, again, this methyl, that carbon has 3 H's on it. 3 H's on a carbon means there are at least 2 identical groups, the H's, so it's not chiral. Same for that. No methyl group will ever be chiral. This carbon has a methyl, a CH, an H, and a chlorine. That's 4 different groups. Again, a CH and a CH3 are different groups. Carbon is the same, but the groups are different. So I'll put a star there. That's a chiral center. This carbon has an OH, an H not shown, a methyl, and a CH. So that carbon is chiral. 2 chiral centers. The maximum number of stereoisomers we can find for this structure is going to be 2 to the 2. 2 to the 2, it's always 2 to the number of chiral centers plus isomerizable double bonds. There's no double bonds here. 2 squared is 4, so there are 4 possible stereoisomers. Go ahead and hit pause and draw them. Draw the 4 possible stereoisomers. Okay. So let's just arbitrarily put both groups coming out at us. Alright, there's one stereoisomer. Now how do you make the other one? Well, we could just change one of these chiral centers. So let's change the OH. Alright, so the chiral center with the chlorine, I kept the same. I kept the same configuration. Chiral center with the OH, I inverted, I switched. Okay, so what is the relationship then of these two there you go. What is the relationship of these 2 stereoisomers? Well, one chiral center stays the same, one inverts. So they're not mirror images. In a mirror image, both chiral centers invert. They're not the same because one changed. So therefore, the stereoisomers, they're not mirror images, they're diastereomers. D for diastereomer. So what would your other chiral centers be? Well, you could put the chlorine, you could put that chlorine back. So let's change both the chlorine and the OH. Okay? So now what is the relationship of this structure to the first 2? Well, the relationship of the upper right structure to the lower left structure, again, is going to be diastereomers. One chiral center, one chiral center changes, the chlorine. One chiral center stays the same, the OH. So these are diastereomers. It's a relationship between these, the top 2. Both chiral centers switch. So that's the definition of a mirror image. If both chiral centers switch, so these are going to be enantiomers. Alright, there has to be, our equation says there should be one more stereoisomer out there. What would that be? Well, that would be then if we, going from the first one, if we switch the chlorine but leave the OH the same. Right, so the chlorine chiral center inverts. Chlorine goes from out to back. The chiral center with the OH stays the same. So again, on the diagonal, those are diastereomers. What's the relationship between the bottom 2 structures now? Again, both chiral centers invert. Chlorine goes from out to back. The OH goes from back to out. The carbon skeleton stays the same. If If you want to convince yourself of this, pick this molecule up, turn it over, and it'll be the mirror image of that molecule. So these are enantiomers. How about the two structures I drew here? Well, again, chlorine's back, OH is back. Chlorine's back, OH is out. So the chlorine chiral center stays the same. The OH chiral center inverts. These are diastereomers. All right, so when you do that, if you're just going to sort of at a glance decide that one chiral center has inverted or the other stays the same, the carbon skeleton, the rest of the molecule, has to stay the same as well. If I sort of fold things up or rotate bonds, I can't just do that at a glance. I have to go in and calculate RNS. But the easiest way is to use this equation. Right? You're not going to want, I'm probably going to ask you a few times to draw all the stereoisomers for a structure, but in real life you don't want to do that. You just want to sort of use this equation. Count the chiral centers, utilize the equation.